still waiting on Sylvie then, Danielle?
Yes, we are. She's just she's trying to work out a technical issue, but I'm sure she'll be on soon. I'm keeping a close watch, but I think it's a good idea we get started.
Okay, very good.
Here she is.
Something's happening. Very good stuff. She on? Looks like she was joining. Sylvie, are you there?
I'm here.
Okay, very good. Then.
I'm just trying to open your Google Doc. Where is it?
Well, Sylvie, while you try to figure that out, I'm going to start. Good morning, everyone who is joining. My name is Matt Blackson. I'm the Executive Director of Team A BlueTech. Want to welcome everyone to our monthly BlueTech Global Connect webinar. Today, our topic is space applications, Earth observation, and the effort to protect our planet. We have arranged a fantastic panel today. Our moderator for today's discussion is going to be Sylvie Giruad,
oh my God,
from Sales and Marketing and Business Innovation at the CLS Group. Presenting companies are going to be Valerio Perusini, the head of commercial development and geoinformation at Telespazio in Italy. Then we have Yann Guichoux, the co-founder and CEO of eOdyne in France. We have Alex Halterman, the Director of Technical Program Development from Quartus Engineering out of the United States. And to round out the group of speakers, we have Carlos Gaitan, the co-founder and CEO of Benchmark Labs out of the United States. So before I hand this over to Sylvie, and for those who do not know, TMA BlueTech is a San Diego, California-based nonprofit that promotes sustainable, science-based ocean and water industries. Our tagline is promoting blue tech and blue jobs. We are based on the triple helix approach, which brings together academia, policy, and industry to further the cause of sustainable blue tech. Our three areas of focus are economic development, business ecosystem development, and national and international outreach. Our 14th annual BlueTech Week conference will be held in person again this year from November 14th to the 18th. BlueTech Week is one of the world's premier BlueTech conferences, and we bring together a fascinating array of high-level professionals from around the world to talk about the state of BlueTech through the lens of academia, industry, and policy. The theme for this year's BlueTech Week will be One Earth, One Water Cycle. We will put the link in the chat box for those of you who want to reference our event for more info. If you would like to follow TMA BlueTech on LinkedIn, I will put that link in the chat box as well. So we are recording this webinar, and for those of you who would like to reference this webinar at a later time, you will find this video on our YouTube channel within 24 to 48 hours of this event concluding. So a few housekeeping topics. Our presenters will have about 10 minutes each to present. At the 9-minute mark, I will give a signal that there's 1 minute remaining. Other than this, Sylvie will facilitate the discussion, especially the Q&A at the end, where we should have about 30 minutes for discussion. If you wish to ask a question, write it in the chat box, and we will make sure it is asked during question and answer time. So with that, I would like to hand the table over to Sylvie. Sylvie, the floor is yours. Sylvie, you're on mute. Sylvie, you're on mute. Okay. She might be having technical issues still. Valerio, if it's okay, we would like to start with you until Sylvie figures out what's going on after that. So the floor is yours, Valerio. Thank you.
Okay, thank you, Matt. I share my screen. Okay, can you see my presentation?
Yes.
Okay, so good morning and good afternoon, everybody. Thank you for the opportunity to be a presenter and a panelist in this interesting webinar. So I am Valerio Perusini, Head of Geoinformation and Commercial Development in Telespazio. I work in this company since 30 years, so have certain knowledge and experience of the company and of the sector. So it's a pleasure to present my company today. Telespazio is a company that is in the market since more than 60 years. However, we are pioneers in a constantly evolving market. And even today, we still think like a startup, transforming the space sector's momentum change into opportunity. I think this is a key message that I want to convey, the fact that we are always at the front of the innovation and at the front of the leading edge technologies related to our business. So we deal with geoinformation, satellite communication, space operations, and digital ground segments. Telespazio has two main shareholders, Leonardo, an Italian very important industrial group of defense and security and technology, and Thales from France. We are part of the Space Alliance, where our system company, Thales Alenia Space, takes care of the manufacturing of the satellites, whilst we are in charge of the services and operation. And as I said in the introduction, we have more than 60 years of experience, and we have more than 3,000 people around the world. Our international presence is more than 15 countries, particularly based in Europe and Latin America, as you can see from the view chart. And we do have in our domestic markets a number of spaceports, space centers and teleports, the most important of which is the Fuji Space Center. Is here in Italy, is active since 60 years. I want to underline this point. As you can see, we have more than 170 antennas operational in this center, and we have 42 control rooms, 5 of them working on a 24/7 basis. This is just one of our space centers, the most important, but as you have seen in the previous slide, we have a number of other infrastructures around the world. Our business, I mentioned the geoinformation, that is the focus of today. We are present along the whole value chain of the geoinformation, being a satellite data operator, particularly in the radar domain, thanks to our constellation Cosmos Skype, that is an Italian asset that belongs to the Italian Space Agency and Ministry of Defense. Is a dual system, very important and very powerful. Then we are a data access hub with access to practically all the main satellite Earth observation missions available. Then we have a strong heritage and experience in content development and delivery, providing value-added services to our customers through our platforms. And then we have a strong also experience in consultancy in our domain. Apart from the geoinformation, as I already mentioned, we are very active in satellite communications, one of the historical business of the company. Space systems and operations, when we work in some of the most important programs at European level, like Galileo, Cosmos Skymet, Prisma, OPSAT, and so on. And digital ground systems, that is another core business for the company. Apart from our structured business that I just mentioned, it's important to highlight that we are pioneers of the future. We are continuing innovating, and so we are very active currently in the field of exploration, working on the lunar economy, working with ESA, working in the International Space Station. We are very active in navigation services. We are a key player in Galileo and EGNOS. We have developed our own platform to provide drone as a service. The name of the platform is T-Drones, and we apply this platform particularly for the Earth observation and geoinformation business, and we are very active in the space domain awareness and traffic management. So focusing on the geoinformation, it's important to mention that since we have more than 100 million euro business in this sector, and we have more than 600 people working in this domain, we are a leading global player in the geoinformation in the international market. We are present in 15 different countries that we consider our domestic markets. Plus, we play the global game thanks to a number of partnerships with a number of players around the world. Our offering is structured thanks to a number of application platforms: Sea-on-Sea for maritime, Braint for defense and intelligence, AgriGeo for agriculture management, Aware for asset management, and MapCI for emergency management. All these platforms provide a number of value-added services based also on the latest technology of big data analytics and artificial intelligence. And CLEOS is our last development, is our marketplace to access all the analytics and geoinformation digital services provided by the company. CLEOS has been developed by eGeos, and eGeos is the core engine of the Telespazio geoinformation business. It's a company 80% Telespazio, 20% Italian Space Agency, and eGeos own 100% of GAF. It is another key player in the sector with a strong reputation at international level. So now I will quickly focus on the maritime domain, considering that we are in the BlueTech webinar. I will give you just some quick example of how one of our platforms, the Sea-on-Sea platform, works in the maritime domain to provide value-added services and valuable information to all our customers, both in the business and in the government areas. So, of course, the blue economy from space, we have a number of advantages to address this topic from space, because satellites have global coverage, can acquire everywhere, multiple times, all weather, and we can count on multiple sensors: radar, optical, hyperspectral, and so on. So thanks to this technological asset, we can cover security and enforcement, trading, market and business intelligence, marine resources management, and environmental protection. I will not go through the details of this slide, but just quickly to explain which are the kind of products and services that we can deliver thanks to our technologies. So from systematic monitoring of global areas of interest using multiple sensors, going through ship detection, oil spill detection, wind and wave maps production, anomaly detection, and so on and so forth. All these services are provided on a 24/7 basis, which is, of course, a strong differentiator in the market. And we can provide these services as a service, also on premises on our customers, including installation, operational training, and data provisioning. So quickly, some example of what we produce. For example, satellite ship detection based on radar. We can very well identify the ships in the area of interest in an automatic way, but also not only radar, but also optical. For example, this is a Sentinel image coming from the Copernicus program. It's very powerful, the oil spill detection service from from satellite. You can perfectly identify oil spills processing radar images. And like how you can imagine, we can correlate an oil spill with a ship and try to find the polluter and inform, of course, the authorities about that. We produce.
We have about a minute left. You have about a minute
Thank
left.
you.
Yeah, thank you.
I'm closing the presentation. So I spoke about wind and waves production from radar images. We do a lot of activities of anomaly detection, looking for strange things happening on the maritime domain. And we work with several databases. Of course, we can have global and systematic monitoring based on, for example, sentinel images, providing kind of patterns, but we can also combine with the AIS, we can also combine with VMS. By combining all this kind of analysis based on big data analytics, we can provide, for example, phenomena like this, an example of anomalous behavior, non-collaborative vessels that are not providing their position and their data through AIS, but we can discover them thanks to our satellite images. This is all. I hope I was in my time, and thank you for your attention.
Thank you very much, Valerio. I do have some questions myself at the Q&A part of this, but thank you very much for that. Sylvie, would you like to take over as moderator right now? You're on mute.
Yes, thank you.
Thank
I
you.
apologize for this. Actually, I've prepared a short presentation I would like to share with you. And maybe we can start by that. So sharing, okay.
We can, yeah, there we go. We can see you're going on full screen. Very good. Okay, thank you.
Thank you very much. So it's my pleasure to present you some insights about what we are talking today, the use of satellite observation for downstream applications. So I just started with CLS, which is the company I'm working with. The mission of CLS is actually very aligned with this webinar, and our motto is to protect the planet and the people on it since 1986. Our mission is actually based on passion, and so to say it differently is to design and deploy space-based solutions so that we can understand and protect our planet and manage its resources sustainably. Sustainable is at the heart of CLS. So just to insist about it, because the green economy in the European Union policy is really based on decarbonation and having a sustainable future, just like I showed before. And so we are working in 5 strategic sectors. The most important share of our revenue is from environmental monitoring and climate. It's not only the ocean, the marine-based activity, but also land and atmosphere in a way. We have then the sustainable fisheries management, which is dealing with the fishing sectors as well as authorities in charge of fisheries management. We then have the mobility, the energies and infrastructure business unit, which is in charge of supporting the majors in the energies and their transition into marine renewables, or renewable, let's say, solar and marine, as well as providing some oil spill monitoring services. Marine safety is very related to what was shown before by Telespazio, and it's about detection of vessel at sea, and more generally speaking, having a situational awareness of everything that happens at sea. And last but not least, the mobility, which is more land-based fleet management. So we are very proud that 90% of our activities are directly contributing to the UN SDGs. I hope you are familiar with these goals for a sustainable planet and to be reached by 2030. Going fast, just to show you our network, where we are 900 employees present in 34 locations, and we are present in every continent of the world, in every ocean of the world as well. So how do we get there? We were established by CNES, the French Space Agency, in 1986, and we were mandated to operate and commercialize the Argos satellite and telemetry services under a MOU with the US NASA and National Ocean and Atmospheric Agency, and we had to establish a company in the US named Service Argos, which were mirroring the operation center in France. And one of our key points also was the launch of Topex Poseidon and kind of give birth to space oceanography. This is one of our first expertise in the ocean monitoring, environmental monitoring. And then all over this period, we had made some external growth by acquisition of a different company. I just highlighted it's not very comprehensive. The idea is to give you a flavor. How do we our external growth strategy was based on that. And after that, I will show you the strategy with respect to the different market segments. So we acquired in 2015 Tre Altamira, which is mostly based on ground motion monitoring. In 2018, we acquired also Woodsell Group, which is a leader in environmental monitoring, and we turn into the Argos legacy system into a new space system by the creation of Kineis, which is a startup actually that had raised 100 million euros fund, and now preparing the launch of nanosatellites next year. And in 2020, we had a new shareholder, a private equity, and the CNES is still our shareholder, but lesser. He moved to Kineis, and then lastly, we just acquired a new company, eOdyne, which is to strengthen the marine renewable market. So just some insights from a very interesting report. I would recommend you to have to read. It was issued by EUSPA, which is a European Agency for Space Programs. And this is a market analysis of 17 market segments that are using EO stands for Earth Observation, of course, and GNSS for Global Navigation Satellite System, which is a GPS system in the US, which is a Galileo system in Europe. So globally speaking, the revenue enabled by these two systems are 200 billions in 2021 and 500 billions in 2031, meaning a high growth. If we focus on Earth observation, which is actually the focus of this webinar, it's also expected to double. The revenues are set to double in the next decade, reaching up to 5.5 billion in 2031. And in the in this figure, you can see the fastest growing. I hope you are familiar. So along the 17, actually 14 market segments only, they make projection, and the market share in 2021 compared to the market share, the projected market share in 2031. And we can see that there is really one sector that is growing fast and more than the other is the insurance and finance sector due to parametric insurance contract. And to adapt, this was a good introduction to explain you how the external and internal growth also strategy of CLS to position on these different market segments. And we had so Sears, for example. So you can see on these lines the turnover, the revenues with respect to the market segments I just shown, and you can see that the top five represent 55% of the total revenues in 2021 again. And also that we CLS position with external acquisition like Sears, for example, in the aquaculture sector, and also mostly also in the energy sector with different acquisitions in the US, but also in South Africa, in Tasmania, in Brazil, etc. So these are strong pillars. We are particularly strong also in the emergency management and humanitarian aid, and in the maritime and island waterways, which is more related to what Telespazio just showed. So as I belong to the fisheries and aquaculture, you can see that it's quite the smallest market, the smallest revenue, but just need to be the best in your category, and that works. So that's the reason why
you have about a minute. You have a minute.
Sorry?
You have a minute.
I will conclude. This is the end. So how do we become the leaders in fisheries? We had the exclusivity to use to operate and commercialize Argos system. Argos is a telemetry system, is more related to the transmission via satellite of the position of the device that is using this system. Is not purely SATCOM. As we said, it was the precursor. It was something different, but that was very useful to track any mobile on Earth, including wildlife. And so we were the first in the market in 1986. And since then, we are leaders, meaning being the first in the market with an innovative system that was developed by the CNES, our mother company, was a key to be the first. In 2020, we launched this new VMS for artisanal fisheries, meaning we extended the market initial for industrial fisheries down to the artisanal fisheries. And now we are enabling the positioning with Galileo, which is a EU flagship navigation system, and with Kineis, which is a space IoT new constellation. In terms of EO, we are leading the market with the processing and science inside to the tuna fisheries, and we are delivering habitat maps to them so that they know where's, just to make it simple, where the fish are, and to optimize their fishing operations. So thank you very much for, this is a short film, but I will just for explaining that we are, sorry, there are some slides about more details about what we are doing, but I just wanted to thank you for your attention, and looking forward talking to you later.
Very good. You will be moderating the rest of the panel.
Thank you very much.
Absolutely. Sylvie, you'll be moderating the rest of the panel unless you'd like me to continue.
No, please continue.
Okay, excellent. Then we'll go next with Mr. Alex Halterman. Alex, would you like to take it from here, good sir?
Yes, thank you.
Absolutely.
Pull up my slides real quick. Hopefully you see the right presentation. Excellent. Well, yeah, I appreciate being included in this panel. My name is Alexander Halterman. I am the Director of Technical Program Development for Quartus Engineering. We're based out of the United States in San Diego and Herndon, Virginia. I'm excited to talk a little bit about our involvement in Earth observations, and we'll be talking specifically about some work that we're doing developing semi-custom instruments with some funding from NASA from a small business innovative research grant, SBIRs. So getting into things, I want to start with a little bit of an introduction of who Quartus is and how we work with our clients. It's really worth noting that we're an engineering services provider and product development company for our clients, but we can really meet you really wherever you need us. And that can be at the outset of a program, understanding what the requirements are, flowing down requirements, helping to define potential statements of work for us to work with, to really delivering a turnkey solution. And what you can see along the bottom is an example of an airborne LiDAR system, which is representative of the instrument development flow that we engage with people on, where we define requirements and carry that all the way through towards post-delivery support. At a certain point, toward the end of the builds, which we try to tie to all of the early requirement development, we can either continue on with post-delivery support, or if our value starts to fall off as we get towards higher volumes. We're a very engineering forward company, not a contract manufacturer. So at that point, we can facilitate a transition to a contract manufacturer to ensure that the clients are getting the best resources for their money. We're a little over 115 engineers, and about 60% of those are mechanical analysts. So a lot of the work that Quartus does engages with clients in this little vertical here of doing just analysis, where clients provide us designs to be analyzed and we deliver them reports. We engage in a lot of different markets, a lot of different industries, and you can see a little bit of a smattering here. It's kind of a busy chart, but on the left, you can see a lot of the work that we do with that kind of 60% of the analysis business, which is a lot of aerospace work. So whether that's launch vehicles, spacecraft, aircraft, or other more niche analyses. And then the other side of our business is the systems development, where we engage in robotics and automation and mechatronics and mechanisms. And a lot of this is in areas where generally available solutions aren't going to meet your needs. So Quartus can provide very custom tailored automation or other mechanical, electrical software solutions there. And then where these two really meet is a lot of the focus of today, which is in precision engineered optical systems, airborne, spaceborne instruments, mechanisms. And you can see there's a little bit of color coding on where we currently engage in the BlueTech community and where we see a lot of opportunity for our future engagements to grow. And today's focus is really going to be on the spacecraft, remote sensing imaging side of things. And so Quartus has been around for 25 years. Here's a little bit of a timeline for our engagement in working on spaceborne observation instruments. We started as 4 engineers providing engineering services, and have grown into a company of about 140 employees. Again, the majority of those are engineers. And throughout that period of time, we've been engaged in various aspects of spaceborne observation. All the way back to 2002, where we started with our first planetary observation, which was actually with the Mars Reconnaissance Orbiter, where we provided structural analysis. And that is indicative of where we started as a company. And our progression as a company actually mirrors very well our progression with spaceborne observation, where we started providing analysis. That transitioned to a large amount of engineers. I think at one point we had 25 engineers with a total of, I think, 117 working on the James Webb Space Telescope through their career at Quartus. And that was a 16-year engagement that started in 2005 and finished when it launched last year, which is very exciting for the science community. And then in the last decade, we started getting into more smaller Earth science, Earth observation instruments, beginning with analyzing work similar to the structural work we did on the MRO with Planet, formerly known as Skybox, which has a constellation of space-based or Earth observing space telescopes. And then the last 6 years has really seen a lot of science instrument development, primarily centered out of NASA Langley and funded by the Earth Science Technology Office. So a lot of that work is looking for low TRL, low technical readiness, so new concepts for continuing the collection of data that we do for Earth science. And I'll talk explicitly about SAGE in a minute, but we've also done some radiometric monitoring instruments where you're understanding the energy coming off of the Earth, working towards understanding the full climate models to see how global warming is happening, hyperspectral systems, and a lot of this is pushing towards these kind of semi-custom instruments. And in 2019, Quartus was awarded the NASA Langley Small Business Subcontractor of the Year Award, which was a great honor for a lot of this work that we were doing. But getting into some of the specific Earth science that we've been involved in and how that leads to future missions, I want to talk about this program SAGE, which stands for the Stratospheric Aerosol and Gas Experiment. And this is a mission that NASA Langley has been running for over 4 decades. Congress, the US Congress mandates that NASA monitor the atmospheric ozone. And this is part of doing that. And it basically stares at the sun. And as the satellite orbits the Earth, you get a sunrise and a sunset. And when you see the colors of a sunrise and a sunset, that's indicative of scatter or absorption at different wavelengths. And so this instrument looks at that for us to be able to understand if there's ozone or methane or other aerosols that can contribute to kind of the greenhouse effect. And one of the challenges is you get very limited data, but it's very, very precise. So the SAGE-4 concept is to push forward this idea of miniaturization and a distribution of measurements. So taking what is currently a single instrument flying on the International Space Station, miniaturizing that such that you can have multiple instruments making more routine measurements to build out the data product better. NASA Langley engaged with Quartus early, bringing a systems engineering approach to this design, leveraging a lot of our simulation-driven engineering. And at the end of this development effort, we ended up with an instrument that was about 10 times smaller and 10 times reduction in cost. So very exciting. And right around this time in 2017, the Earth Science Decadal Survey came out, and it was calling for a reduction in space-based Earth observations, reduction in cost. And there's always going to be these large flagship missions that you want to try to keep costs down on. But we advocated that significant gains can be made by saving costs across the board on these smaller missions that typically don't get to benefit from any sort of economy of scale. So at the end of this program, we see a nice telescope, which you see there on the right, and realize that you can take the components of it and potentially repurpose them for all sorts of other instrumentation development. And if you can validate and truly believe the engineering tools that you use to do that beyond a particular program, which is generally there isn't money available to do, then you can validate those tools and accelerate and reduce the cost of future missions. So we received funding from the NASA SBIR office to pursue this and effectively amortize that investment over the cost of future missions. So what's really exciting about this is you can take this architecture and think of it almost like building blocks for really precision science instruments. You can get different apertures, so you can collect more light, you can do different things in that area. You can change the field of view. We are doing a very narrow field of view, just looking at the sun. You can change the system to look at a wide area of the Earth or any other aspects of understanding the atmosphere. And then you can change detectors, and you can change all of the elements that you're using, really to allow you to kind of do more science with less money, if you will, and run these kind of custom payloads. And so the hope is to engage early with the science community, with principal investigators, with commercialization opportunities, understanding the concepts early, and trying to more or less jump from a napkin sketch all the way to a flight instrument really, really quickly. And so that's some of the aspects that we're hoping to engage in the coming years with regards to Earth observation and Earth science. And with that, I'll turn it over. I'm excited to see where the conversation goes and excited to be part of this panel.
Excellent. Thank you very much, Alex. As usual, it's really, I always get more nuggets of information whenever I talk with you about what you're doing. It's really helpful to have these more often than not. So thank you. Appreciate
Happy
it.
to participate.
Excellent. Very good. Very good. Okay, then we are going to continue with Yann. Yann, are you ready to start your presentation?
Yes, I am.
Very good. Well, let's get her started. It's up to you now. Here we go.
I'm going to share my screen. Mhm.
We're not seeing anything yet, good sir.
Going to share the full screen because I don't see the window. So
There we go.
can you see the slides?
We can. We just have to do the full screen and then it'll appear properly.
Okay.
Looking better now. Is that the full screen? There we go. Thank you. Thank you.
Thank you very much. So first of all, thank you very much for the opportunity to present eOdyne. So I'm the CEO of the company, and eOdyne is a French company. We are based in Brest, in the west part of France. And our activities was born thanks to the new space technologies and the new data sets which were collected thanks to new device. And eOdyne is a new maritime company which exists thanks to the new space. So just a short presentation of the team prior to the presentation of the activity. The company is the team is composed of 11 people, so with 5 doctors in the company, all experts in remote sensing, Earth observation, statistics, and applied mathematics. And we are developing a new technology, a new activity to monitor ocean surface currents. So our core activity is related to ocean observation. So to do so, we are using a new, let's say, a transformative technology which rely on the use of ships as a sensor of opportunity. We are using machine learning to analyze the ship motion and to retrieve information on ship drift and then on ocean currents, waves, and wind. So I just want to show you a short video explaining what we are doing. The English of the speaker will be better than mine, so it will be clearer that these short explanations.
World maps of ocean currents are produced mainly by radar satellites periodically scanning the globe. This technique does not fully meet the maritime sector's expectations. eOdyne's innovative technology brings new solutions based on ship dynamics analysis and machine learning algorithms. The technology gathers AIS data sent from every vessel across world oceans, where there are more than 100,000 vessels sailing at any one time. These AIS data are collected by a large number of telecommunication satellites. eOdyne processes this data to produce complete, high-resolution ocean current maps spanning the entire globe. The technology turns any vessel into an ocean current sensor and delivers a global map of the currents actually observed at the surface of the ocean in real time. Thanks to its technology, eOdyne delivers innovative solutions for safer, cleaner maritime shipping, ocean energy, and state action at sea.
So this was the concept explained by an English, in a perfect English, I would say. Just now, an example of the output of our algorithm to be more precise. Here you can see some AIS tracks of the Algerian coastline. And thanks to our algorithm, we're able to monitor surface currents. So we are analyzing the ship motions, and you will see some ADs, filaments, and oceanic features here. which can be observed thanks to the motion of the ships. Each ship is acting as a light ray, illuminating the surface of the ocean. And thanks to this technology, we are able to have a global, real-time ocean surface current maps. So this is a world premiere. eOdyne is the only company in the world dealing with this technology, which is patented. And here we can see the typical coverage one can get with the technology. Here you have 10 days of AS signals covering the entire globe, except the poles, the Arctic areas and Antarctic areas. But as you can see, we have a very, very impressive coverage. Yeah, another example of the output of our algorithm. You can see here the Gulf Stream in the Atlantic, showing eddies and filaments, which are detaching from the mainstream. And as a complement, I would like to explain that our technology can complement altimetry satellites. In the past, altimetry was the only mean to monitor surface currents on a global scale. Now, thanks to eOdyne technology, which is also called omni-situ technology, we are able to monitor surface currents and to complement altimetry measurements just by the use of a digital solution. So the technology was born in 2013, and we made a lot of validation with several organizations, as you can see on this slide, with the French Navy, with the European Space Agency, CNES, and some industrial partners such as Total Energy, CMA CGM, and so on. And our main markets are related to the shipping industry, the offshore energy markets, the defense sector, and some others, like the insurance sector, and of course, space and satellite calibration and validation. What you have to know is that the market we are working on is we are trying to develop is already existing, but in the past it was mainly remaining on altimetry measurements, and eOdyne is now able, thanks to our omni-situ technology, to develop and to transform all the existing services relying on altimetry. So this is one of our goals in the future, to be able to develop in partnerships with some companies, including US companies, new products and new services relying on a more reliable and more precise ocean surface currents information. A few examples of the products we are developing. Here you can see some a video of the platform we are using to provide surface currents monitoring to our customers. So you can see altimetry measurements on the screen. And the high resolution product is our omni-situ product based on AS analysis. You can see the two beautiful eddies in the Arabian Sea off the Spain coastline, and you can see that they are matching what we can see with our technology. Another service we are developing at the moment is Seaways. Seaways is a weather routing service. So you already know Waze for selecting the best route for your vehicles. Here the idea is to select the best route, the optimal route, to save fuels and to limit CO2 emissions in the shipping industry. And to do so, we are feeding the system with our technology on the maps we are creating thanks to the motion of the ships. And to be able also to deliver the service on board, we developed a device. Here you have an example of the outputs of some data collected by this device. You can see white plots on the screen, which are corresponding to AIS tracks, which are collected by our EO box on board of ships. And this EO box is able to provide on board ocean surface currents compute thanks to the AS data collected in the neighborhood of the ship. And this is a typical service we are developing It's still a service under development. It's not finalized, but we are making progress. And the goal of this service is to provide to the ship a short-term weather routing service. This is what you can see here. The selected ship was able to save up to 5%, 4% of fuels using the route we were able to provide thanks to our currents. Thanks to this technology, we are also able to provide or to develop new services, innovative services. So I talked about ocean surface currents, but the technology also enables to measure wind and waves using the same kind of algorithm. And here you can see some on the right side of the screen, an example of the output of the algorithm showing the correlation between a low pressure area seen with our outputs and AIS information on the top of the image, and another one with scatterometry measurement from a space mission. And
yeah, you have about 1 minute left. I'm sorry to interrupt.
Okay.
Thank you. Thank you.
Okay, that's the end. On the last slide, just to explain that our technology has a huge potential for many sectors involved on all related to the maritime, and we are open to discussion and partnerships to try to develop any kind of service which can enhance the health of our ocean. So if you have any question, do not hesitate.
Excellent. Thank you very much, Yann. I spoke with you before about your technologies, but like with Alex, it's good to see it again. More additional questions we'll have for you in the chat box. So without further ado, we need to move along to Carlos. Carlos with Benchmark Labs. I'm really looking forward to what you have to present. So with that, and the floor is yours.
Thank you, Matt. Perfect.
Excellent.
So thank you very much for the invitation. Thank you for the audience for coming at all these presentations. I'm Carlos Gaitan, CEO of Benchmark Labs. We provide asset-specific forecasts for the agriculture, energy, and insurance sectors. What we want to achieve as a company here is to reduce operational margins, to improve operational margins and reduce water consumption and energy costs for owners of fixed assets. And why we do this is in general, because traditionally, weather technologies all over the world for the last 80 years have been based on the concept of dividing the world in boxes. They divide the world in boxes, smaller boxes, little boxes, but overall, those boxes represent a big area. And that works well for national security, for aviation, for synoptic scale movements that are going to cover a wider area. But if you are a farmer, and it could be an agricultural farm, a wind farm, or even as some of our users call themselves as no farmer in ski resorts, you actually care about what is happening at your asset level more than what is happening at the county level or at the country level. So that's why we created Benchmark Labs, to reduce those uncertainties that are prevalent in gridded models and refine those weather forecasts from leading organizations like the ECMWF in Europe, NOAA, Department of Commerce here in the United States, Environment Canada, and so on. They all divide the world in boxes. And what we do, it's in many ways, we linked IoT sensors in situ with this information of the gridded models. And why is this important? Because insurance, energy, and agriculture all share the same problem that in a nutshell is referred as a spatial basis risk. And it occurs because these uncertainties in the observations, some, for example, in the insurance companies, think about that they have to create products that are priced based on information, and that information is imperfect because the owner of the fixed asset has the information of their farm, but that information is not publicly available, or the insurance company only has information from the nearest weather station that sometimes it's located at a university campus or at a government building that has like a totally different land cover, land use, and even microclimate than that were recorded from public weather stations. So that asymmetry of information gets translated into more risk that then translated into higher premiums. The same thing or the same situation happens in energy and in agriculture, where this information from gridded models do not address microclimates, and microclimates could occur because you are near a seashore. You could have sea breezes affecting the direction of the winds. You could be near a lake in the Great Lakes, for example, depending on which area you are in Canada or in the United States, for example, snow or no snow will happen, and you're probably under the same grid of the weather models. Similarly, there are changes of elevation. If you talk about agricultural producers in the Mediterranean region, they value the terroir, what is unique, and they understand that that uniqueness is what creates value for their products. It could be just fruits, or it could be something more elaborate like wines. And because of that terroir that is happens at the microclimate level, those models from the weather agencies are not designed to solve them and to create actionable forecasts and information at that location. So what we do is, in a nutshell, we link geospatial technologies, satellite, IoT sensors, and leading information from weather models that also are based on observations, simulation, radio sounds, auscultation, weather balloons, aviation. All of those information systems are part of the current generation of weather forecasting models globally. So what we do is we use the IoT models, the IoT sensors as ground truth, and we correct those biased models using IoT information to provide a personalized in-field forecast that is actionable to the owners of these fixed assets. Our patented technology has a great impact on forecast accuracy, and it reduces the errors, for example, in temperature, up to 60%, 66%, relative humidity, wind speed, wind direction, precipitation. It depends, of course, on the number of observations. But you see that these reduction on the errors have like huge implications, especially for food security, for operational applications in farm management and energy management. Labor scheduling is a huge problem. We are not only better in terms of reducing the mean absolute errors and improving correlations, but also in our resolution of extreme events, how we address days below 0 Celsius, 32 Fahrenheit. That is, it could determine the difference between losing everything from a crop for frost or not. Heat spells, OSHA regulations here in the United States prevent the labor if temperatures are above 37 Celsius or above 95 Fahrenheit, 100 Fahrenheit. So all of those ones affect the labor scheduling and has like also a profound impact on operations. Moreover, our technology, and we recently received also support from the California Seed Energy Commission, because our technology reduces water consumption up to 25%. Specifically here in California, 50% of the water use goes into agricultural uses, the state level. However, there are still practices that are not optimized. For example, people often irrigate without taking into consideration if Mother Nature is going to provide free water in the form of rainfall, or sometimes the irrigation schedules are in times where the evapotranspiration is higher. And so our technology provides in situ evapotranspiration. And for those of you that are not familiar with evapotranspiration, consider them that are like the losses of your bank account. Most of the solutions out there focus on precipitation, that are the inputs, how much you receive in your paycheck. But there is no much clarity or information regarding how much you use every month. So our technology provides this asset-specific information of how the plants use water, and that leads to a personalized ET evapotranspiration forecast. We can even further refine it using satellite information, using information of some of our previous panelists, for example, where you can create NDVI indexes. That's a normalized vegetation index. You get a crop coefficient, you multiply it by the evapotranspiration that you have been measuring, and then you can create a more accurate crop coefficient and evapotranspiration estimates at the farm level. So as part of this experience, when talking with Matt and the people here at TMA, they mentioned that our audience might be also interested about our path. So we are a very young company. We were created in 2019, and I just wanted to share some of the metrics or like our pathways that led to where we are now. In 2019, we created the company. We received pre-seed investments from NextView Ventures, NASA awards to work on drought forecasting, especially during COVID time, to see how the presence of COVID would affect basically control burns, or the absence of control burns, and how that will impact forest fire management and the drought conditions all over the US. And we entered a plug and play InsurTech accelerator. That's how we got also an understanding of our value to insurance companies. On 2021, we entered TMA. We're supported also by Clean Tech San Diego, and we're building the connections with the energy sector to understand the use cases for wind and solar generation. As you can imagine, for solar generation, they are also affected by microclimates. The presence of a cloud could totally affect how much solar power your installation is producing. And the same thing with wind farms, even the location of the wind array of turbines affects the production. So not all the turbines produce at the rated speed always. So there are microclimates even created because of the array of the wind turbines. So we are exploring our applications in energy. We receive a National Science Foundation SBIR grant and support from the San Diego Economic Development Council that very kindly have been helping us providing interns from local universities in business development, marketing, and other areas. In Q3, we entered Techstars in partnership with the Nature Conservancy, got our first paying customers to provide environmental forecasts at different preserves globally for control burns, and customers in agriculture to release our in situ measures. They are very happy that we improved versus the current alternatives. And we started signing partnership agreements with IoT sensors. Thank you. On 2022, just recently, we got the California Seed Award for our evapotranspiration estimates. We got support from the World Trade Center Microconnect program for export and commercialization programs. And then we are raising our seed round. And just to finalize, the TMA had helped us giving access to government grants and programs, networking and events like these ones, internship opportunities, and office space here at UTC San Diego. So I just wanted to thank all of our sponsors and be here as a resource for anybody in the audience that wants to see how these observation technologies are being used at a smaller company as we scale. Thank you very much for your time.
Thank you, Carlos. Thank you very much. It's great to see what you're working with, and that we've been able to be helpful, of course, at TMA, but that you're doing great things. It's great to see that. Really happy for you. Look, we don't have a lot of time within the scheduled time for Q&A. So I am more than happy going over just a little bit to get to some questions, because we do have quite a few. So I'm just going to start with first one coming in. How can this is coming in from Hogne Anderson. He's from Norway. how can Earth observation play a vital role in ensuring sustainable food production? So that would be to all of the panelists. And if you could try to keep your answers, short. That's okay.
Okay, this is Valerio. I can try to give a first very quick answer to this question. I make a concrete example where I mentioned in my presentation that we have developed a platform based on drones. And so we use drone technology for monitoring, for example, node-shift plants in plantations in crops. And it is very powerful. And for example, we know that this technology is used to detect datura in the crops, in the corn crops, and it's very, very useful. And our business is being deployed now in Europe, and is a way to demonstrate how Earth observation, in this case from drones, is helping the food security and food sustainable production.
Okay, Sylvie, would you like to answer?
Yeah, our sustainable food production, if we refer to the blue economy, it's fishery. Fishery produce food, seafood. Let's say, if I can say so, we through to our system and Earth observation, we can predict areas where are the most we say fishing potential zones, and where we can go with very advanced scientific methods to provide services for these big fishery, tuna fisheries, for example, to go where there is the least smaller fishes. I mean, to go where there is more adult fishes, and not to fish sustainably, not fishing undersized fish, fishing more the adults, and because actually the financial benefit or the economic revenues are higher with bigger fish. So actually we help them to have a better strategy, a better economic strategy for them. So this is a combination of observation and science.
Thank you. Yann, I'm sure you have some things to add in this regard.
Can you repeat the question, please? Because I missed it.
No problem. So how can Earth observation play a vital role in ensuring sustainable food production?
I'm not a specialist of food production, but what I can say about food production and the fisheries related to our activity is that we are able to enhance the way we are monitoring surface currents, and these surface currents have a strong impact on the spread of phytoplankton, and this phytoplankton is, of course, the food of the fish. So in terms of fisheries activities, the better we are able to monitor ocean and surface currents, the better the fisheries will be efficient and will avoid also to spend too much time at sea, using fuels, emitting CO2s, etc. So this is an aspect where I think ocean observation and new technologies related to surface currents monitoring can help.
Thank you. Alex, any thoughts?
I mean, I think that there's a kind of a common thread in a lot of this, where I mean, it's really more data allows smarter, I guess, logistics management, and I don't think I've got too much more in the limited time we have to add to what other panelists have said, but I certainly see there being a wealth of information available from all these developing technologies that hopefully can address a lot of the challenges of the planet these days.
Thank you very much. Carlos, do you have any thoughts on that?
Just in the aspect of Rob? Hello?
You good?
Yeah, you're fine. We can hear you. There's just a little bit of echo in the background.
Yeah, thank you. So in terms of Earth observations, we focus it in as IoT sensors, agricultural sensors, leaf wetness sensors, soil moisture sensors, full-blown weather stations, and they helped us to save water and energy at the farm level. Also, by having this kind of information, we reach or help users reach sustainable goals also by removing or like reducing the number of pesticides and fertilizer use as they rely on environmental conditions. So we also reduce eutrophication at the river streams. So yeah, basically water, energy, and environmental health.
Okay, got you.
Thank you.
I know that Silvio is going to, Valerio is going to need to leave here in just a few seconds. So I do want to thank him. Thank you, Valerio, for participating in today's discussion.
Thank you.
We had a lot of questions actually, and it's just it's sad we can't get to them all because they're all really good, right? But if you got to go, that's great. But I mean, to the rest of the sorry, go ahead.
So I want to thank you, Matt, for the opportunity again, and I am ready. If there are many questions, I am ready for a second round. Okay.
Very good. Very good. We can send them out. Thank you.
Pleasure. Bye-bye.
Cheers.
We're going to have to jump off shortly as well, but I feel like there's an opportunity to dig into a bunch of these questions and follow up afterwards. So happy to continue the conversation.
Okay, very good. If Yann or Sylvie or Carlos would like to stay on just for one final follow-up question for everyone, that would be fine.
Yeah, perfect.
Yes, I can.
Excellent. Very good. Very good. Well, you know, there's so much going on right now, and we talked about your sciences and your know-how. It's really quite cool. But you know, just to get a little bit of emotion in here, you know, what is really exciting for you in the next few years? What do you see coming that you know makes all of this worthwhile for you? Getting up in the morning. So, Yann, or actually, Alex, since you have to go later, is that okay?
Yeah, no, I've got just, you know, I think one thing that's just really, you know, interesting is the rate of development, you know, and what new space brings. I mean, if you look at the barrier of entry for satellites, for instruments, you know, a decade, 2 decades ago, I mean, I think it was like $25,000 a kilogram to launch into space, and now it's a small fraction of that. And as you start pushing things like, you know, SpaceX's Starship and things like that, which the price tag on that is just, I mean, it would have been unfathomable like two decades ago to think that you could put something in space for so little money. And so I think what's exciting about that is that you're able to be a little bit riskier with the development activities. You're able to push things quicker. You're able to, you know, you don't need to fly a 7-figure NASA NOAA collaborative, you know, instrument to be able to gather the science or the data that's needed to make world-changing decisions. And the way that things are going, you know, the ability for innovation to be supported by such a low barrier of entry is exciting, because you can push, you know, maybe more abstract, wild approaches, and they don't all have to pay off. You don't have a, you know, Six Sigma design approach to space anymore. You can, you know, I don't know that you can shoot up 100 satellites and only 80 of them will work, right? And that's just a different approach. And you know, we're excited about that. I mean, it's a little bit of the approach that we're trying to bring on. What I was talking about earlier is this, you know, driving down cost for precision instruments, and I think a lot of that ease of entry and availability of the resultant data products from that, I mean, they're going to be what we need to bring to bear to address a lot of the world's problems. And hearing a lot of the panelists already applying the data that's already becoming more prevalent, I mean, it's inspiring. So I'm excited to see where it all goes, and you know, the reduction of cost to get that data and the speed with which you can get new data products and new ideas. You know, exploring that is, you know, it's like nothing we've seen.
Very cool. Yann, how about a French perspective? Let's hear it.
The French perspectives. I think the new space, the new device, the new systems, into orbit, and the new way we can process all the data which are collected thanks to this system is making the revolution. I think machine learning, artificial intelligence, and all these new technologies related to data science, and the very large amount of new data collected will change the way we can observe the Earth, and will transform also the services, and I expect for a more sustainable world.
Fascinating. Love it. Sylvie, any thoughts?
Yeah, definitely. I do agree with my colleague. New space is a game changer, and we are happy to be in with Kinace. What really excites me when I go up in the morning is every day I'm just how can I say that? Surprised by the creativity and innovation, for example, and this is not from CLS, for example. I'm not going to be corporate, but anyway, for example, Unseen Labs, which is a new company. Yann, you may know them, a small company. Now they have found a way to detect vessels in the sea, because there are some limitations to Earth observation, right? We cannot see every time, everywhere, etc. So there are some limitations, and some can be, can I say, complemented by drones. As you said, you have a local surveillance. But anyway, now you can have provided that this system is able to localize or to have kind of identity of a vessel through the passive electromagnetic signature. So meaning that we don't need to, they don't need to have a beacon on board reporting their position, or the regulatory or radar satellite that just spot the images, but you can have other possibility from space to detect things. So that just, oh wow, they did it, etc. So every day new ideas, every day new things. I was thinking another thing I forgot, but I think yeah, definitely also something from the US, Laconic Enterprise, which is I think major there. Now they have put edge on board the satellite, meaning edge computing, meaning that one of the key things when you making surveillance using satellites is that you have to task the satellite, provided that your customer want to observe a given, I'm talking about surveillance, right? A given area. So, and now they have made kind of artificial intelligence on board the satellite so that you could task it much more easily and have the data, process the data on board so that you transmit very fast, only maybe less data, but the thing. So having faster, the idea is to having the change I can see, the progress I can see is that we are moving towards having faster the data from space with this kind of innovations, and that's really good.
No, that's fantastic. That's a really good point. Thank you. Just the speed by which things are progressing and data that can be transferred is super cool. Really, really cool. Thank you for bringing that up, Sylvie. And of course, we've got Carlos. Any thoughts? This will be the last insight we have before we conclude for the day. So make it a good one.
Thank you. No, I think that what keeps me like motivated, it's how many problems are still in the world that aren't met, and how many ways that you can find novel ways of solving a big problem for users. They might be not the biggest problems that have been tackled by many before us, but there are still significant number of challenges that affect the livelihood and the operations of billions of people globally. So by us being able to make the life of small farmers globally better, that is very rewarding. And we might not be in millions of acres, but the ones that we have under management, we make a difference, and that is what keeps us awake. So I'm motivated. So thank you, Tim.
Thank you, Carlos. That was indeed a good one. With that, we're going to conclude this month's BlueTech Global Connect. Our next one is going to be on June 16th, and the topic is going to be building a sustainable future for our ports and harbors. This is ports related. So we'll have a great lineup of speakers there. So stay tuned for that, or make sure to register if you can. Again, thank you very much to our speakers for participating today. It's been fascinating. And yes, and to our audience, thank you for participating as well. We hope you got something really valuable out of this. Have a great rest of your week.
Thank you.
Cheers, everyone.
Yeah.
Thank you.
Thank you, Matt.
Thank you very
Thank
much.
you, Matt.
Bye-bye.
Okay, bye-bye.
Bye-bye.
Bye.